Hello. What we're going to do, we are going to continue with whatever we did in the part one. Okay. So we talk about the application, of art stats in solving our problem from the practice test number 2. So I'm going to share with you that test again, and then we continue. So this is what we did so far. We talk about how we're going to apply the application to do the binomial problem, number 1 and number 2. Then we talk about the normal distribution, and we did problem number 5, 6, 7, and 8. Okay, and all the problems can be done by using TI-83, 84, or manually. So there are two more problems in the case of the normal distribution, which are going to be very important in everyday life, number 3 and number 4. You see in the previous problems, in order to solve the normal distribution problem, we use the normal curve. And the situation is you are looking for the probability. So we know that the probability is going to be area under the normal curve. And that area can be done by, can be found by using a table, TI-83, 84, or just art of stat application. Now we're going to do a kind of a converse problem. The converse problem is going to be the area would be given to you, which is the probability in percent. And then you want to find the actual X values. What is the variable, or what is the situation and the probability that corresponds to that given probability, if you like. So there are two types of problem. This number 3, you take a test to be qualified, you apply for a job. So there is a test that you have to take, and there is a minimum score that you have to earn to be able to be hired. Okay, this is type 1. The type 2 is you go and purchase something, they offer you a warranty. Okay, the warranty, they talk about 4 years, 3 years. We want to know how you, as a company, you're setting up the warranty so that you are not going to give away many, many free items. And we want to investigate to see how they set up these type of ideas. It's like when you order a pizza. They say we deliver it in 10 minutes and it's going to be hot. Otherwise, it's free. How they determine that it's only 10 minutes, okay? So this is going to be a situation I'm going to create it. So I'm going to explain. There are two types of problems. So I explained part 1 first. Number 3. You see, in number 3, what we have is there is a condition from the score point of view to be higher. So if you want to be a member of this elite organization, requires to test the score in the upper 30% range. So we know that X is the scores and X is normally distributed. So it's a normal situation with a mu of 115 and a sigma of 12. We want to find the minimum scores that you require to be able to be accepted into the training. So this is how we're going to set up. We change it to the normal curve. We identify the 30%, and we find a lower score for this. Okay, so let's go back to my notebook so I can explain it for details for you. So this is going to be number 3. So and this is it. You are going to explain that the test score, the test score. Okay, the test score X, if you like, is a normally distributed, or normal distribution, normally distributed. Of course, as soon as you say normal, you have to give us two numbers. The mean, and the mean mu is going to be 115. Okay, and the sigma. Sigma is equal to 12. Okay, that's the case. And this is, of course, your normal distribution curve. So this is going to be normal distribution curve. Okay, you know that the center is going to be the mean. So what are you interested in? You know that if you want to be accepted into the club, your score must be in the upper 30%. Upper 30% means if this is going to be 30%, so you must be here. Okay, upper 30%. So this is the 30%, the leftover is 70%. So your score must be bigger than, okay, or larger than 70% of the other, other members, if you like. So this is 70%, and the leftover over here is, that's a 30%, that's a 70%. See a score, and the curve would give you the area to the left of the number. So this means you have to find. So one should find, if you like. One should find a number. Okay, a number x0, so that p of, you see, p of x less than or less than equal to the x0 to be equal to what? To be equal to the 70%. Okay, you must be here, of course. The probability that p is greater than x0 is 30%. But since you want to find it from the table, so you have to get the area to the left. Or if you like, or you can do this one. Find z less than z naught to be equal to the 70%. If you want to go to the z curve from the table. Okay, so if you want to do it manually, this is the way you do it. You go to the z score table. This is the z numbers, and this is the percentage. So you look for the 70%. So look for the number, it's going to be close to the 70%. You see, this is the first time that you get to 70%. 0.705, 0.54, etc. So the smallest number is going to be this one. 70, this is 70%. But you can play it, more precisely. If you pick this number, 0.6985, and you run that gives you 70%. So 70% would correspond to the z number of 0.54012. So if you take your number z naught to be 0.52, that corresponds to the 70%. Okay, so there you are. So you realize that. So from looking at that table, okay, you realize that this z naught, okay, the z naught must be must be 0.52. Okay, but that's a z. You have to give us the answer in terms of the x. So the question is going to be, what is x naught? You know that the z score formula that gives you z equal to x minus mu over sigma. You substitute, your z is 0.52. Is going to be your x is missing minus mu of 115 over 12. You do the algebra. Cross multiply, so that gives x minus 15 is equal to the 0.52 times 12. Okay, 0.52 times 12. If you use your calculator, that gives you 6.24. So add 115, so your x would be 115 plus 6.24. 6.24, and if you add them together, that gives you something like 121. 121 0.24. Since it's a score, you can run that. So your X is going to be almost 121. So this is the least score that you need to be able to qualify. Okay, so this is going to be the lowest, okay, the lowest acceptable score to be able to get to the, okay, to get to the numbers. Okay, this is if you want to do it yourself, just using the, manually. So the important part is identifying. And some people, most of people, they miss this one. They use the 30%. But remember, the table, the Z-score give you area to the left only. So you have to consider 70%. 70% if you want to go to the table and find it. Okay, but these 70%, 30%, they are percentile. Remember the percentile that we did before? So what you can do is you can use the application, art of stat application, and find this one quickly. So I'm going to go back to that application and show you how I'm going to do it quickly. Okay, yes, so let's go back to the art of stats. So I'm going to share it with you so that you know that where you are going to find it. Okay, so this is going to be art of stats. You share this one, and that's it. So we got the art of stats. So click on the art of stats. So you go to the web. You can go with a cell phone. Also it's free just to try it. But the web application is free. So we need normal distribution. So go back, go down, down, down to get distribution. Okay, that's a binomial distribution that we use in a part 1. And this is going to be the normal distribution. You get the normal distribution. Okay, this is the normal distribution. Look at this one. The top is find percentile. So previous one, we used the probability. Now for this problem, we are going to find the percentile. Okay, that's it. So what you are going to do, you are going to put your mean here. Okay, the mean was 112, 115. So that's 115. Okay, and the standard deviation. So what was the standard deviation is 12. A standard deviation is 12. So what you want, you see the one to the left, lower tail. The lower tail or the upper, it doesn't matter. If you go with the lower tail, the area to the left, this would be 70%. So that gives you 70%, and you look for the number. You see, for the 7% percentile, the value of X is 121.29. The one that we did using the manual case. Okay, so very easy. You better use this one. But you got to be careful. Okay, that's I use the lower tail. If you want to use that 30% that we talk about, look at this. If you want to use the upper tail, if you are going to be interested in the upper tail, remember in that case, you have to change this one, okay, into 30%. 30%. If you change it to 30%, you get the same number. 121, okay, and that's it, 121.29. Okay, so we suggest, of course, this one for the application. And if it's going to be on the test, we accept it right away. Okay, great techniques and easy to find. So if you go with the 30%, you have to draw the problem for yourself to see which one are you going to be interested in. Okay, the upper part or the lower part. Okay, so be careful. So I go back to the notebook to show you. See, that's one. If you want to stay with the 30%, you are interested in remember, the range is upper 30%. So for the percentile, check the 30% and make sure you get the mu and the 115 and the 12. So that gives you the result right away. 121, 24. So X must be 121. So be careful which one is going to be your final answer. Okay. Very easy application, really. You better use this one to get these problems. We have quite a lot. This is one of those cases that as an application of we call it the converse to the normal, okay, normal distribution. This is where the area is given to you. You want to find the value for the X, okay? So that's number one. We have another one. We check it to make sure that we have no difficulty to get this one. Okay, so if you go back to the practice, practice test, and you see the next problem that we are going to have. Okay, what was let me just bring back that test so that we can see it. Okay, I missed that test. So let's bring it back and explain that problem quickly to get this one done. Okay, so this is the second part. That is going to be, I don't have it here, so I have to check it again to get the situation that I have. Okay, so let's check this one. Okay, the next case was the case, oh yeah, I have it now. So this is it. So we can do this one using application right away. So number 4 is you want to set up a warranty. Okay, you want to set up warranty for the CD players. Okay, usually people buy CD players. So X is going to be number of the years that the CD player would work normally. And the mean number of the years is 7.1 years, a standard deviation of 1.4. So what you would like to do is you would like to set up set up the warranty so that you always you have to replace only 2% of the CD players. Okay, how long are you going to make that? 2 years, 3 years? Okay, so you decide yourself. Well, of course, you want to give away, okay, as few as many you can of the CD player. So again, draw this one, draw the curve to see what the situation that we have. You can do it manually again, but AutoStat is much, much easier. So let's go back to my notebook. I arrange it, then I come back and I do it. Okay, so that was number 3. So in number 4, the X number 4. So in this case, that is going to be that the number of years. Okay, so let's say the number of years X is normally distributed. You have to tell us it's a normal distribution. Normally distributed. Again with mu. Okay, the mean is 7.1 years. Okay, and a standard deviation of 1.4. 1.4. So get the normal curve again. So this is going to be your normal curve. This is going to be normal curve. Okay, so what you would like to do is you would like to give away as few as, okay, a free CD player as possible. So the area that you're going to be interested is going to be only 2%. You see, the 2% means that if you set up your, okay, if this is going to be a number of years that you're going to be interested in, okay, so if anything happened to the, okay, to the CD player in this area, okay, if the number is going to be x0, if this is going to be number of the years, okay, if it's going to be 2 years, for example, if anything happened during the first 2 years, then you have to replace it, but otherwise you don't have to. So the way you are going to set up this problem is that you have to find a number so that the area to the left of that number is going to be 2%. This is important because you know that when you go to the application, it's the lower on the upper. Okay? So if you want to do it manually again, you have to find x, find a number, okay, a number x0, so that area to the left, the probability that x is going to be less than x naught is only 2%, which is 0.02. You see? So the percentile that you're going to be interested in is going to be 2%, and this time is a lower tail, lower tail. Again, if you would like to use, you do it manually, you have to find what is the number corresponds to the 2%. You see this one? At 2%, you start with a number where you see 0.2 in this table. You have to go to the negative part for the Z numbers. You see, that's it, 2%. Where you start with the 0.2. You see 0.2? Where is the smallest one that you can get? You see, this is the one. So over here, you have 0.2119, okay, in this case. So go on to get the smaller part. 0.0, 0.0, 0.0, that, you see this one? 0.002. So this is almost, okay, this is going to be almost 2%, but you can be more precise if you pick the next one. If you round 0.1977, that gives you 2%. So you can maybe pick this number. Now these numbers correspond to the Z of what? Okay, if you check this one for the, okay, if you want to check the 2% in this case, okay, so I'm sorry, I made a mistake. 2%, yes? 2% would be 0.02. Okay, I need 0.02. So let's go and check 0.02. 0.0, 0.0, 0.0, 0.0. And that's it. We get the 0.02 here. 0.0228, 222, 1712. You see, 12, 07, 002. So that's exactly what we are interested in. Okay, so what is the Z numbers correspond to this? Is a negative 2.05. Okay, negative 2.05. So the Z number, okay, so this is going to be the same as, of course, you know, application is much easier, but I just explained it to convince you. Okay, you want to find this. But according to the Z table, this Z naught, if you like, is going to be negative 2.05. Okay, negative 2.05, but you have to find the X. So the Z is equal to the X minus mu over sigma. Yeah, so that's going to be negative 2.05. And we get the X. X is missing, minus mu, which is 7.1, divided by sigma, which is 1.4. Cross multiply. So X minus 7.1 is 1 minus times 1.4 times negative 2.05. Okay, if you move it to the other side, that gives you 7.1 plus 1.5 times negative 2.05. You multiply the other part, 7.1 minus, if you use your calculator, it's going to minus 2.87. And eventually your x is going to be equal to the 4.13. It's years, okay? It's a guarantee, so x is going to be 4 years. So if you guarantee your item for 4 years, then you are not going to be forced to give more than 2% of your item free. Okay, so this is just show you what would happen if you want to do it manually. Okay, now the important part is some people they made a mistake here. You see, this area, 2% to the left is the other problem was to the right. Then we have to consider the complement, 30%, remember we consider. But since using the application is going to be lower tail, 2%. Okay, so if you go to the art of stat again, and this is what we expect you to do it on the test, okay, it would be easier. So let's go and get our application again. Okay, so I have to bring that application back. So I go to the art of stat. Okay, I have to refresh this. Then I get the applications, art of stats. And that's it. Going to the art of stat, going to web, down, down, down to get the normal distribution. That is the normal distribution. And remember, you are looking for the percentile, finding percentile. So you put the mean of scores is 7.1. Okay, so it's going to be 7.1, and the standard deviation of 1.4. So that would be 1.4. 1.4. We are interested in the lower tail of the 2%. Lower tail 2%. See, that's it. You will see it's like the one that you suggested. So lowercase and the number of value for the x, value of the x is what? Is 4.225. 4.225 is exactly 4. Okay, you round it into the 4 years. Okay, very easy application, and you better use this one. But make sure that you give us the result for the lower tail this time. Area to the left, 2% for the guarantee. The other one, remember, you want to find the upper one. So just make sure to pick the correct answer. The answer is not this time, if you get the upper one. So this is the only two possibilities. You may be interested in the lower one, or you may be interested in the upper one. Okay. So we suggest you use this application, which is very easy. Okay, but give us a graph of the situation. Okay, and then use the application. You are welcome to use it. Great applications for this one. Okay, so if you want to use it, you have to explain it for us. Okay, explain what you are talking about. Okay, and why the problem would end up with this. You have to tell us this. Okay, you get this one, good for you, because you want to know what is the lower tail or the upper tail. So as soon as you identify lower tail, you go to the table and find it. For the problem of the scores, they told you to be into the upper 30%. So identify 30%, so the percentile of the 30%. Or the other one is the tail of the lower tail, and it's going to be 30%. Okay, nice application. Okay, so we are done with the problem of the binomial distribution. So two problems in the case of the binomial distribution that we're going to have. Okay, so the problems are going to be the one that directly we are going to be interested in finding the probability, and the other one was, the other way around. Okay, so that is the problem of the normal distribution. Now we go back, we have two more concepts to consider. Okay, so the next one, which is very important, again, this is one of those type that is missing in your book. They talk about it that this is optional, but it's very important to be optional because we need it for the confidence, confidence interval. So let's go back to the test and explain the next problem. There is a tricky part of this problem that you have to be careful. Okay, what is this? This is the idea of relationship between binomial distribution and the normal distribution. You see, normal distribution is very easy to apply. But the problem with the normal distribution is this x must be a continuous variable. Means x can be any number. But in the case of the binomial, x cannot be any number. X can be only 0, 1, 2, 3, 4, 5, 6, discrete variable. And for the binomial distribution, when the sample size is, if the sample size is going to be big, it's difficult to take care of the binomial distribution. But there is a condition that if that condition is satisfied by your normal distribution, then you can change that normal distribution, that binomial distribution into the normal distribution. When we get to the normal distribution, application of that art of stats give you the problem right away. Okay, this one we call it the normal approximation to the binomial. Now, what is the difficulty? You see, look at this number 9. Records show that 29% of all payments to a mail order company are submitted after the due date. It's like when you pay your credit bill, if you like. So some people will be late. Okay, in this case, we have 29% of the population, they are late. It's like a proportion problem. Okay, so 29% are going to be late. So what we do, we are going to pick a sample of 50 payments, okay, and we want to answer the following probability question. So what is going to be the probability that more than 20%, okay, this is like must be the same symbol, okay, but we're going to change them, okay, either X or R. I'm going to tell you why. Okay, it doesn't matter. Let's talk about X or take this one to the R. So we pick, X number of the people or R number of the people are going to be late. We want to find what is the probability that more than 20 people will be late, and what is the probability that less than 25 people will be late. It's a binomial case. If you have a good calculator, or even if you use art of stat, you can do it right away. Because you have the P25, okay, the sample size of 50, and the numbers that are going to be interested is 20 and 25. But from the mathematical point of view for future, and I did it for the, estimation of the proportion, we need to have this type of argument. We want to approximate this one by a normal distribution. Now, how are we going to approximate it with the normal distribution? And so what we do is, if the sample size is big, there are two conditions to check. Remember, if n times p would be greater than 5, n times q would be greater than 5. Let me just go to my notebook and explain the rest over there for you. Okay, so this is a situation. We call it normal approximation to the binomial. So on the test, this term would be given to you. Otherwise, you can use a calculator and do it right away. But there is a change that you have to do, okay? So this problem number 9 and, number 9 and 10, these are going to be normal approximation. It takes time, but with the application, very nice. And you have to do something first yourself. Normal approximation to the binomial. To the binomial distribution. This is part of estimation that we do, in chapter 7, 8, and 9. So normal approximation to the binomial. So what is this type of problems? A binomial situation would be given to like this one. Okay. So what you have in this problem is the variable x, if you like, in this problem, the variable x, which is the number of the payments, late payments. X is a binomial distribution, is a binomial distribution. Remember, when we say binomial, you have to give us the following with P, probability of success of 29%. When the people, they miss the payment, 0.29. Then you have to find the Q. Q is the leftover. Is 100 minus 29% or 1 minus 0.29. Okay? You get this one that give you 0.71. Okay, 0.71. And the sample size. The sample size N. N is equal to the 50. It's a big number. Okay, this is the situation I'm going to have. So what is the question? The question is going to be, you want to use the normal distribution. Okay, change this one to the normal distribution to answer this question. The question is part 1. What is the probability that x, I use the same variable, is going to be greater than or equal to 20? And what is the probability that x is going to be less than or equal to 25? Okay, that's the situation you're going to have. So these are going to be your question. Again, you can use the art of stat application to get the as is, but they ask you to use normal approximation to the binomial. For the normal approximation, you have to check the condition first, and you have to show this. Conditions. The condition for this problem is n times p must be greater than or equal to 5, and n times q must be greater than or equal to 5. You have to check this condition first. If this condition satisfies, then you go ahead. If it's not satisfied, you can't do it. Okay, so it's easy to check. We check the first one. So what is going to be NQ? NP. N is sample size, 50. Okay, times 0.29. Okay, the calculator, you find this. Okay, this is going to be, we have the 50 times it by 0.29. Okay, so that give you 14. So that give you 14.5. So it's going to be equal to the 14.5, which is greater than 5. So we are fine. Which is the second condition. N times Q is going to be 50 times 0.71. Okay, 0.71. Again, it is going to be 50 times 0.71. You check this one, that give you 35.5. 35.5. This is bigger than 5. You see, both conditions satisfy. Now you can claim that the normal approximation can be applied. Can be applied. Okay. If you want to change it to the normal distribution, you need the mu and you need the sigma. Okay, we need these two, otherwise we can't do it. Now, how are we going to do it? Remember, binomial distribution will tell you that mu is n times p. You already got this one, which is 14.5. That is going to be your mean. Sigma. Remember, the sigma is a square root of npq. You substitute n times p is 14.5. So you're going to have the square root of 14.5 times it by 0.71. 0.71. So I'm going to check this one. Okay, that's it. The square root of is a 14.5 times it by 0.71. Okay, then the square root. I didn't get it. Okay. So it's a 14.5. Let's see what's wrong with my argument. Okay, this is it. I double check it again. I have a 14.5 times it by 0.71. And the answer is this one. Okay, 3.208. I'm going to call it 3.21. Okay, so the sigma would be 3.21. Okay, there you are. So from the binomial distribution, we get the normal distribution with this, okay, with this mean and mean and the sigma. Now we bring the question of the probability that we talk about it. Now, the situation that you're going to have is that you see in the case of the binomial, so let's check that part one first. The part one, you want to find the probability that x to be greater than or equal to the 20. You see, if you stay with the binomial, this means 20, 21, 23, 24, 26, etc. But when we go to the normal, you have to use the continuous variable. So what you have to do is you have to put this x into an interval so that you can pick any number. This is the one that if you watch the lecture notes that we talk about it, this is called correction. Okay, correction for continuity. So this, we have to estimate this. That's why I use two different notation, x and the r, but you can stay with, the same notation. So what we are going to do, remember, this is dot, 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 dot. But we want to change it to an interval. The way we do it, you see this is 20. That's a 20. So we are going to make this one, we are going to find an interval containing 20. See, to the right, to the left. There are many, many intervals that contains 20. But the one that we're going to pick is, we go to the right and to the left, just 0.5. Okay, 0.5. 0.5 to the right, 0.5 to the left. Point right to the right, that give you 20.5. Okay, and 0.5 to the left, you have to reduce it. That give you 19.5. You see, now 20 is going to be in this interval. Now, P of x greater than or equal to 20, you see 20 is, you want it to be greater than. 20 is greater than what? 20 is greater than 19.5. So what we're going to do is, we are going to change that x into the x. Okay, x greater than 19.5. That's why, again, we can start with the r here, that to show that this is, okay, this is This is a discrete number, then you change it. So you see, if you start from 19.5, you see 19.5 to the right. So 19.5 would cover the 20 here. Okay, so it's always the case. X greater than 20, we change it to the X greater than 19.5. So since we are going to use all the numbers in this interval, so that will give you the 20 up. Okay, so from the binomial case, we go to the normal case. So this is where you can use the art of stats, because this is the normal distribution with the case of the, okay, it's a normal distribution with the mu of 14.5 and the sigma of 3.21. Okay, go to the application and get this probability right away. So your main job is this changing description. This is the kind of estimation that we do, and it's useful because we are going to use it and get it. We already done it with the proportion. Okay, when we estimate the proportion, we did the same thing. Okay, so now we go to the art of stat application, and we find this probability. So let's go back to the art of stat, our applications, and come back and do the job. So going back to the art of stat. Okay, let's share this one. Oh, I'm sorry. I have to refresh this to. So now going to the art of stats. This is art of stat. Again, you need to go to the normal distribution. Okay, web application, especially for this type of problems, is quite useful because it takes time to be able to do this. So this is your normal distribution, and you are interested in the probability. So you put the mean of 14.5. Okay, 14.5. That's your, sorry, that's 14.5. That's your mean, a standard deviation of 3.21. So that give you 3.21. 3.21, and what you want? You want the probability X greater than 19.5. So this is not a good one. So greater than. That's a greater than, and the X number is 19.5. 19.5. And that's it. 19.5 probability, you see, probability that X is greater than 19.5 would be 5.97%. So the probability would be X greater than 19.5 would be 5.970%. And then you're done. Okay? So most of the people, they missed it. They don't use the 19.5. They use 20. You cannot use the 20. You have to, because 20 is just one number, 20, 21, 22, 23. You have to give us an interval. So it's a 19.5, greater than 19.5. That give you the number right away. Otherwise, if you want to do it continue manually, you have to change this one to the Z, and it takes time. So great application again, but it's a kind of estimation that you have to do the first part yourself. So there are two possibilities. There's going to be another one. The important part is just a correction for continuity. Okay. So the answer to the first part is 5.97%. So the probability that R, if you like to be, or X, greater than or equal to 20 is 5.97%. You can check art of stat with the binomial distribution. You get the same answer, but this is different. Okay, that's the first part. The second part, what would happen if it's going to be less than? Okay. So the second part, you want the probability. You better use the R and the X so that you understand it. Okay. In the binomial case, you want it to be less than 25. Again, you have to change it. That's why I use two different notation. So you want to change it, correction for continuity. We call it CC. Correction for continuity, that should give you something like X less than. Less than what? You see 25? This is 25. 0.5 to the right, 0.5 to the left. This is 25.5. This is 24.5. Okay, both of them contains 25. But what do you want? Less than. Less than. You see, if you want to consider to be less than 25, 25 is not less than 24.5. 25 is less than 25.5. So that gives you 25.5. Okay, so the way you pick it, you must have the same direction. Less than, less than, less than. So if you pick X to be less than 25.5, you are going to cover 25. Okay, and this would give you an interval. So be careful. You see this one that we did, or this one, it was greater than. You see, you can change this one to the R if you like. It's a greater than. So greater than, this is 29. So 20 is greater than what? Is it greater than 20.5? No, it's greater than 19.5. So that's why 20 greater than 19.5. But over here is a less than 25. Less than 25. 25 is less than what? It's less than 25.5. Okay, so there you are. Again, you go to the art of stats. You find this one, this probability for the same mu that you have it. Okay, mu of 14.5 and the sigma of 3.21. If you go back to the application, you already got all those numbers. Okay, so go back to your application. You see the first part is the same, but the difference is this one. You are going to be interested in less than. So you are going to be less than, but your number is different. Okay, your number is 25.5. 25.5. Okay, 25.5, and this is going to be the probability. 99.97, almost 100%. Okay, so the final answer for this one is going to be probability that R is going to be less than or equal to 25 is going to be 99.97%. Okay, so the probability part, of course, out of stats, give you a very nice one. But make sure that this, you have to change it into the, okay, change it to the probability of X to be less than X. And the X is 25.5. That's it. That is normal distribution. Okay, normal approximation to the binomial. It's a great thing, you know, it's like in calculus, the way we do it. And there is a nice formula for it. We can prove it. We can prove that in that case, you are going to get to the, okay, you need a little bit of calculus too, to be able to, okay, to connect it. But officially we made it for you, okay? So we give you one of them on this coming test. Just make sure don't miss the correction for continuity. You have to give us the conditions, show that it satisfies these two conditions. You have to find the mu, n times p sigma, square root of npq, okay? And then two different cases, okay? You have another one, I can explain that one too quickly so that make sure you understand it and know how you are going to do it, okay? So let's go back and get that practice one again. so that I can explain it, okay, for you. So let's get back to that practice one. I missed it. So I have to bring it back. The second problem, just give you one case. Okay, not going to be two cases because it takes time. But it's a very great application again of the that you are going to have it. Okay, so let's see what is going to be the second problem. I have to refresh these so that I can see that. So let's get to the second problem of the normal distribution. This is the way we are going to give you just one case. Look at the problem number 10. 2% of hair dryers produced in a certain plant are defective. Estimate the probability that a sample of 10,000 randomly selected hair dryers, exactly 225 are defective. Use normal approximation to the binomial. By itself is a binomial case, but the sample is 10,000. So you must have a very good calculator if you want to do it by the binomial case. But of course, they ask for the normal approximation, okay? So you want in this time to get it so that you get exactly 225 to be effective. This is type 2. The type 1 was just using, okay, inequality. This is the one that we have, okay? So we're going to set up the problem. You have to explain it, show that you can use the normal approximation, then go to the, okay, go to the table and get the result. So let me describe the problem for you. Number 10. Number 10, what you have, we have a binomial case, you see. So it is a binomial case. Binomial distribution with, you have to give us three numbers. Probability of success, 2%. 2% of the dryers. 0.02. You have to find the Q. Q would be 98%. 98%. 0.98. Sample size, huge. 10,000. Okay, so what you have to do, you have to check the condition first to show that you can do it. Conditions, and you have to write it down on the test. Conditions. Conditions is you have to show that n times p is greater than or equal to the 5, and n times q is also greater than or equal to the 5. We check. So n times p, n is 10,000 times p. P is 0.02, 2%. Okay, 2%, so that gives you 200, which is very much greater than 5. So the first condition satisfied. Okay, so the first condition satisfied that we have. Okay, then we check n times q. That is going to be n times q. Okay, what's going to be n times q? N is 10,000 times q. Q is 0.98. Okay, 0.98. So that gives you again a huge number. Okay, it's going to be 98 with 2 zeros. Okay, because we have 4 zeros, but 2 zeros would be done because of the decimal point, which is very much greater than 5. So we have nothing to worry about. Okay, so normal approximation. normal approximation. Normal approximation can be applied. But what is the mu? And what is the sigma? So we have to find it. We are in the case of the binomial, so the mu is going to be n times p. Okay, that would be n times p. We already got this one. It's 200. Okay, that's going to be 200. And then we have to find the sigma. Sigma is the square root of npq. Okay, np is equal to the 200. So it's going to be 200 times it by 9.8. Okay, so you have to use your calculator to get these numbers. So I'm going to check. So, and this is it. The first part is 200. 200 times it by 9.8. And then the square root. So I got 14 here. Okay, it's correct. It's 200, and so we get a 14. That's it. So we have the sigma, so the standard deviation is going to be 14. So we have the mean, and that's it. So now we go to the mode of the normal mode. So what's the question? The question is, in the binomial case, what is the probability that R, number of successes, is going to be equal to the 225? 225. Or simply what you want is, what is the probability of 225 in this case? So you have to correct for the continuity, CC. So the CC would be probability of X. You see, 225 exactly. Again, you see, that's a 225. You add 0.5, 225, 0.5, and you subtract 0.5. So they gave you 224.5. So you want 225, okay? Since it's equal to, you see, 225 is between these two because it's equality, 225 is greater than 224.5 and less than. So when it's exact, this is going to be your correction for continuity. So 224.5 less than X less than 225.5. You see, this is the one that you have to find. Okay, so be careful. When it's just the exact number, 225. In the previous one, it was less or greater than. But in this case, it's going to be the exact number. So you put it in this two. So there you are. Go to the table. Remember, your mu is 200 and your sigma is 40. Now it's a normal distribution. Go to the normal distribution table into the art of stats and find the number. Okay, so let's go back to the application. So that is going to be, where is the application? I have to get it again. Okay, there you are. We go to the art of stat again. Okay, get to the art of stack, sharing. Can I have to refresh this? So that's our application. Okay, to the stats web app, go for the normal distribution. Normal distribution, you are looking for the probability, find probability, bring your mu, the mean of 200. Okay, that is 200. Okay, a standard deviation of 14. So that's a 14. Then what are going to be interested in this is between two numbers, okay? So you are interested in this third case, and you put the lower number and the upper number, lower number 224.5, 224, okay, 0.5, and the upper number is 225.5. So that give you 225.5. That's it. You see, in this case, this is going to be your x1 and the x2. And the probability that your x is going to be within these two numbers is very low, 0.579%. Okay? So it's a 0.579%. So the probability is going to be very, very low for this standard deviation. Okay? So again, very easy application, very good one, really. To get these numbers done, just make sure to change it into this form and get the lower number and the upper part. It was 225.5 to top, 224.5 down the bottom. Okay, so I go back, and as soon as we change it to the normal distribution, it is done. So the probability that exactly 225 of those okay hair dryers are going to be defective is going to be very low, 0.579%, almost 0.6%. So that is given one. Okay, so it's a very nice application on this and very nice problem here. But you have to explain it. You see, these are the one. You have to check the conditions. You have to give us the mu and the sigma, and then eventually the application. It's going to be normal distribution. Everything in statistics is going to be nice when it's normal, because we can go back and use the z-score. Okay, so that is application of the okay the normal approximation to the binomial. Now we have one more topics to talk about it. We already talked about this one. It's very easy confidence interval for the proportion. So I'm going to explain that one for you. Let's go back to the test and identify the problem, and then we are going to do it. Okay, so let's go back to that practice one. And just I have to bring that practice one again. This is, of course, very easy problem. And you don't have any difficulty with this one. Okay, this is it, number 11 and number 12. This is confidence interval for the proportion. We give you the formula for this, but the web application is very easy to use. So I'm going to share with you two different methods, the manual one so that you remember it, and of course the application, which is much easier. Okay, so this is number 11 and number 12. So let me just give you the formula, then I come back and do it. So this is a situation that we're going to have. Okay, so that is the case. So the case for the problem number 11 and 12. 11 and 12 is simply confidence interval. Confidence interval for the population, for a population proportion. population proportion P. Remember, in this case, we estimated by the population, by the sample proportion. So the formula that we prove it for you is this. Okay, the P is going to be between, okay, it's going to be between P hat minus the marginal error. Okay, and this then P hat plus E. That is going to be your confidence interval. But E is, so E is equal to the ZC, the square root of P hat, Q hat over N. I proved this one for you the other day. And these terms are going to be, okay, this is going to be the case where, okay, this is going to be the case where E is this and P hat is equal to the R over N. That is sample proportion. Sample proportion. N is the sample size. Sample size. R is the number of successes. Number of successes because it's a binomial distribution. Number of success or the item in your interest. Okay, C is critical value. Sorry, it's a critical level. It's a percentage level. And the ZC is critical value. Critical value. And the Q hat is 1 minus P hat. In your book, they use the P hat times 1 minus P hat, but I change it to the Q hat. Okay? So this is the situation you're going to have. Now, when the problem is given to you, they only give you 3 numbers. Sample size, number of successes, and the C, confidence level. If you check this problem, okay, so if you go back to the given problem so that you can compare it, what we have. You see over here, right at the beginning, 2 different numbers are given to you. The larger one is going to be the sample size. A smaller one is the N. You see, a survey of 300 union members in New York State reveals that 112 favor a Republican candidate for the governor. So N is 300, the sample size. 112 is, okay, is the off. Then construct a 98% confidence interval. This 98% is C, nothing else. Okay, so what we are going to do, we are going to estimate, okay, estimate the proportion of all the populations, all the population of the union members that are going to be in favor of a Republican, okay, a Republican candidates, because this is just sample. Okay, this is the way we do it, and how sure you are, 98%. So that's the case. Now, if you want to do it manually, which is not difficult, really. So let's go back to this, okay? So you identify the sample size, was easy. The sample size, 300 union member. Okay, the number of successes. You are going to be succeeded if you are a favor a Republican or the interest, the portion that you are going to be interested in. And this is 98%. So what you can do is you can find the P hat first. So the P hat is equal to the R over N. Then you substitute that, give you 112 over 300. Okay, Then you have to use your calculator to get these numbers. Okay, the number would be 0.37 or 37%. So the p hat would be 0.37. Then you have to find the q hat. Q hat is the complement. 1 minus p hat, okay, which is going to be equal to the, okay, it's going to be 1 minus 0.37. And if you find it, that gives you 0.63. So the Q hat would be 0.63. Okay, so we got the, see the formula, we have to find the marginal error, we got it. So I have the P hat, I have the Q hat. Then what you have to do, you have to find the ZC. We give you the table the other day for these numbers, okay, the critical values. This is the one that during the lecture notes, I talk about it. You see over here, these are the percentage, and these are going to be the ZC. In this case, you are interested in 98%. So for the 98%, you get 2.33. You have one table in your book, and during the lecture, I give you one. So you need only these numbers. So for the 98%, that gives you 2.33. Okay, so you say that the C is equal to the 98%. So the corresponding number ZC is going to be 2.33. There you are. You substitute to get the marginal error. So the error is going to be ZC 2.33, the square root of P hat Q hat 0.37 times 0.63 divided by N. Okay, N is the sample size, 300. Then use your calculator, simplify this number. So the number would be 0.065. So the marginal error is going to be 0.065. Okay, this is marginal error. Any estimation would have an error. This is going to be your error. That's it. We are ready to give you the interval. So the interval, you substitute, you estimate. So that's it. So you are going to find the p hat minus e, which is going to be less than p hat plus e. You substitute, the p hat is 0.37. So 0.37 minus 0.065 is less than p, is going to be less than 0.37 plus 0.065. So you just get this, so that give you 0.305. Okay, less than p, and that would be less than 0.435. These are probability. You have to express it in percent. So that give you 30.5% less than p, less than 43.5%. Okay, so you have to make a comment. You just estimate it. You say that I'm estimated, I'm sure. I'm sure that how much sure you are, how sure you are, 98%. So there is 98% chance. There is 98% chance that the population proportion of all those union members who are in favor of a Republican candidate in New York is going to be between 30.5% and and 43.5%. You have to make a comment. So comment like this, okay? You have to make a comment, remember. So the conclusion is this one. And you say that, different way to write it down. So there is a chance. So one way to do it is this. And there is a 98% possibility, chance that the population proportion. Okay, the population proportion of all union members, okay, of the, this is of all, that union members is going to be between, okay, between 30.5% and 43.5%. You see, this is if you want to do it manually yourself. Okay, it's good to know, but of course, for everyday life problems, the time is important. So let's see how we're going to do it with the art of stat. Okay, are you ready? Let's go to the application. This time you have to search for the confidence interval. Okay, let's go back to the application and check this one. Okay, if you go back to the application and bring the art of stat again. Okay, let me share it for you, with you. Okay, this is it. So remember, it's from the top, and you just keep going down to get to the, okay, this is the one from the top. You go down, we get to, this is the distribution that we've been using, but go down again. Go down again to get the confidence interval. Confidence interval. This is it. Confidence interval. You are going to be interested in confidence interval for the proportion. From now on, there is going to be confidence interval. We do the same thing for the mean, standard deviation, variance in future. That's what you are going to do for the rest of the course. But we describe it, but we can use the art of stats to do it. So in this part, we do it for the proportion. Click on the proportion. Dismiss the mobile one. And there you are. Look at this. So you want to find a confidence interval. That is going to be confidence interval. So what you have to do for us is you have to provide some numbers. You see this is confidence interval. So you better do this part. You see number of successes. That's it. So in this case, you are going to give us a number of successes. Remember the R. So in this case, the number of success was what? Oh, here. Sample size first. The sample size was 300 union member. So that would be 300. Okay, number of successes, 112. They were favor of a Republican candidate. Okay, this is it. Then you have to give us confidence level. Those three numbers that you be given. The confidence level was 98. 98. That's it. Look at this part. So the point of estimation is just the proportion, okay, sample proportion. That's a p hat. Okay, the p hat that we use is 0.37. They use 0.3733. This is called marginal standard error. In your book, they are interested in this. We are not. This is when you assume that the ZC is 1. But we are interested in this number, marginal error, E. Okay, the marginal error that they got is 0.065, exactly the same thing that we did. Then the interval. This is where we are interested in, interval. You see, this is it. The lower part of the interval is 30.84, is like 31%, and the upper part is 43.5. Okay, it's almost the same as the one we did, and this is going to be the interval. You see, very easy. So I started again. You have to check the confidence level. Okay, confidence level. You have to give us a number of success, sample size, and the number of success. Then just the confidence level, that 3 numbers. Quickly you get it. If you want to do it for the test, you have to give us the following information. Point of estimation, a standard error, marginal error, and the interval, and a comment. Okay, so this would, or just take a screenshot of this page, okay, a screenshot of this page, and then post it into your, okay, into your solutions. Okay, let me write it down so that you know what we expect you to do for us. If you do the art of stats, okay, so I stop this and go back. If you do it art of stats, this is how we're going to give us the information. So from the art of stat, you have to give us what is the, okay, point of estimate, point of estimate. This is this is the one that we estimated with. It's the tool. Point of estimate is p hat. You have to tell us that the p hat from this application is 0.3733. That's point of estimation. You have to give us what is a standard, because you have this in your book. Standard error. Standard error is this one. It's, okay, you know, you don't have to just remind you the formula. P hat Q hat over N. This is point, you don't have to write the formula, just give us the numbers. 279, you're not going to use it, but marginal error. Marginal error. Marginal error is E. E is positive, negative, whatever we have, 0.065. The way we did it. Then the interval. Confidence interval. The confidence interval is nicely given to you. Okay, it's like the one that we did. It's going to be, you know, in percent or otherwise. But we prefer the percent. Okay, it's a 3.084, comma, okay, 0.4383. Okay, or in percent, it would be better. If you rounded something like, you know, 31% and let's say 44%. And a comment. Okay, your comment is, as we talk about it, there is a 98% chance, 98% chance that the population proportion, okay, the population proportion of those union members is going to be between, okay, between 31% and the 44%, and be accepted right away. Okay, so get your application and give us this information. We give you the full grade. Okay, great application there, you see. It is not bad to find it even, okay, as I did it, but this is great, it's already there. Okay, so you have a choice. You can do the art stats or otherwise. Okay, so I have another one, we give you one. I do that one too, so that you make sure that you understand it, but I do it with the art of stats. Okay, and this is a proportion one, so let's go do the last one that we have is going to be the following. Let's share again the practice one that I have. So the last problem, but we give only one. That is the last one. You see number 12. When 343 college students are randomly selected and surveyed, it is found that 110 own a car. Find a 99% confidence interval for true proportion of college students who own a car. So you have one sample, you want to predict it for everybody, okay? You want to know what is going to be the proportion of all the college students who own a car. So as you can see, these three numbers, again, the first number is the sample size, okay? So the first number is a sample size, the bigger one, n. 110 is number of successes, the number that you're going to be interested in, and the confidence interval of 99%. You don't need anything else for the application case, okay? So I'm going to set up the problem and come back here. Okay, so let's go back to my notes, and this is how we're going to set up the problem. Okay, so you have your numbers, you identify, and the sample size is going to be 343. Okay, and that's it. And you have the number of successes, which is equal to the 110. And you have a confidence level of 99%. Go directly to the author stats, use these three numbers, and find the interval, find those information that we talk about it. Okay, so going to the web again. Okay, that's a web with the confidence interval, interference for the proportion. Go to the proportion, dismiss this. You are interested in confidence interval. From the text, change it to the number of successes. Now, check the number. Sample size 343. Number of successes, in this case, 110. Number of the people who owns the car. And the confidence level this time is 99%. 99%. There you are. So this is what we're going to get. This is p hat. Point of estimate is 0.3207. Standard error, and this is the error we are interested in. Positive, negative. It's like the 0.0649, and this is the interval. Okay, the interval is going to be between 26% and the 39%. Nice and easy. Okay, so I'm going to report this, and then be done. Quickly, this is a very good method, okay? So what we are going to report is the following. A point of estimate. So that would be point of estimate. That's a p hat. P hat is equal to the, okay, point of estimate is 0.3207. That's the first part. And the second one is standard error. Standard error. Standard error is 0.0252. Marginal error. Marginal error, which is E. E is positive, negative, 0.0649, and the interval. Confidence interval. Confidence interval is, okay, you have a 0.2558, comma, 0.38, okay, 56, or This would be like, like 26% and the 39%. See it? Comment. The comment is there is 99% chance, 99% chance that the population proportion, the population proportion, those people who owns the car is going to be between, it's going to be between 26% and the 39%. And you're done. Okay, like, I talk about it, when CNN, they report the election, they usually give you this. They give, somebody is winning the election with a 40, they projected that it's going to be 46%, 47%, but they always say with a marginal error of positive negative 5%. So this means it's going to be 5% up or 5% down. Of what? Of the point of estimate. You see the point of estimate is 32%. 32%, 5 up, that give you 39%. 5 down, that give you 26%. So this is the way we do it all the time. And it's quite useful. That's it. As you can see, it's a very nice application that you have. And you can use it on the test, and we're going to accept it. But remember, don't just give us a number. You have to explain the numbers, okay? And give us your interpretation of the number, which is important, really. Be describing the the idea or the data that we already collected. And we're going to continue again using this application through the rest of the course. Okay, have a good one and hope you are going to have a good test on Tuesday. Okay, bye-bye.